Hello and welcome back to my supplement, specifically creatine presentation. So I figured I'd actually break it into two or more pieces because it turned out to be sort of on the long side, and I wanted to limit any given presentation to about 10 minutes. So this is going to be broken up. So returning back to creatine though, just as a very quick recap, how does it work? So in essence, when ATP through hydrolysis is reduced to ADP, then the phosphocreatine, the phosphate basically bound to creatine, donates that phosphate and replenishes ATP. Now let's move on and take a look at some studies. So research is very extensive on creatine, and I will look at both in athletics but also actually in slightly different neighborhoods. So I've basically just selected certain studies because there are many. There are thousands of studies, in fact, on PubMed, and probably the same thing would be true for ResearchGate and any other database search engine. So let's get to it. So Cooper et al. Is a 2012 study, found that regardless form, supplementation of creatine will increase strength and fat-free mass. And this is true for resistance training and also concurrent training. Now, concurrent training is a mix of aerobic and anaerobic modes of training. Then there's this by Creatin et al. In 2017. It's a meta. This actually took a look at long-term supplementation, as worries in the past have been expressed on negative effect on kidney of long-term supplementation. So this study shows, or this meta shows, that 30 grams per day for 5 years is safe and well tolerated in any healthy population, basically from infants all the way up to the elderly. And that it provides significant benefits in a maintenance type dosing. In this case, they use 3 grams per day, but 5 grams is also pretty common, and this throughout the lifespan. So just to make it clear before we actually do move on, a meta-analysis, for those who don't know, is a collection of studies on a topic. It is sort of top of the food chain in research. It will basically summarize all the studies in a given field under certain criteria. So moving on. Now here I just briefly review some select studies on a little bit different perspective on creatine, possibly not as well known as the effect on muscle. And these are mainly they will revolve around muscle damage, how it tends to reduce muscle damage, and also oxidative stress. So Best et al. In 2010, they observed that triathletes would experience a reduction in several markers for muscle damage, most notably creatine kinase, after 20 grams per day supplementation of creatine and 50 grams of a carb source. This is the equivalent of a creatine loading, by the way, about 20 grams a day that will be loading. Also, Cookie et al. In 2009, they observed that following a loading of 0.3 grams per day, so that's about, if you're 100 kilos, then that's 30 grams. If you're 50 kilos, then it's 15 grams. It's about 20 grams if you're 75 kilos. So that's more or less the standard loading of 20 grams per day. And then following a maintenance protocol of 1 gram per day helped reduce loss in muscle strength and damage in supermaximal. So in very high eccentric resistance training, where of course muscle damage will be much larger, as most of the damage, for those who don't know, in muscle occurs in the eccentric phase, they point out here, and this is with 120% 1 RM. So this would actually be very significant muscle damage. And in a recent study by Ronnie et al. In 2011, creatine was shown to attenuate oxidative damage on DNA and lipid peroxidation. Lawler et al. In 2002 found similar anti-oxidative properties, and Optiende et al. In 2001. This is sort of interesting. Noted that basically GLUT4 transporters, they are, for those who don't know, that is how the glucose from the blood find its way into the cell. This is a little bit complicated, but just in very briefly, when blood glucose is elevated, then the pancreas will pick that up through their respective sensors. They will release from the beta cells insulin. Insulin will travel in the blood. It will bind to receptor. It will trigger a phosphorylation cascade in the cell that basically signals from the cell membrane into this little transporter vesicle, which is called the GLUT4 in skeletal muscle. It has different names in different tissues. Also in heart muscle, by the way, that's also GLUT4. It will signal to the GLUT4 to go up to the cell membrane, fuse with the cell membrane, creating a little pouch, so to say, which can then take that GLUT4 and then come back into the cell and deliver the glucose that it has taken from the blood to the respective location or destination. Now, when subjects typically are immobilized, then the content of GLUT4 of these GLUT4s is reduced. Now, what this study found was that this actually was offset. This was offset by a loading phase or a loading protocol of creatine supplementation, and this is kind of interesting, in fact, for multiple reasons, as it's very important for cells to maintain nutrient uptake. Now, continuing on to some meta-analyses and systemic reviews. This is a little bit also a mixed population, but also very strong statements. So Longhurst et al. In 2017 found that creatine supplementation is effective in upper limb strength performance for exercise with duration of less than 3 minutes. Right? Remember the energy system, right? This would then certainly be oxidative if you're oxidative phosphorylation if you're looking at over 3 minutes. And this was independent of population characteristics, training protocol, and supplementary dose or duration. So this is a pretty strong statement. Basically, no matter what you do, you take creatine, it will help you in at least in strength. And similarly, the same authors 2 years earlier found the same results also for lower body strength. Basically, as long as you supplemented creatine, this will help you improve your strength. It's a very, very powerful statement. Then De Vries and Phillips in 2014, they found that creatine supplementation during resistance training in aging or in healthy aging helped enhance muscle gain, strength, and function over resistance training alone. So basically, it helps the elderly maintain muscle mass, which is quite significant because that is certainly one of the big problems the elderly will encounter, is the loss of especially fast twitch muscle fibers. And then Chilbeck et al. In 2017, similarly on the elderly population, found that creatine supplementation increases lean tissue mass in upper and lower body muscular strength in resistance training of older adults. Here we can look at a specific study done by Volek et al. in 2003 on strength and power, and this was on 17 healthy men, 0.3 grams per kilogram. This is a pretty high dose of creatine monohydrate per day for 4 weeks. Showed, as we can see, the top one. It's a little bit poor, the quality of this graph, but we can see at the top one is the creatine and the bottom one is the placebo, and the 1 RM squat is on the y-axis. and then the time or weeks is on the x-axis. And then we can see that clearly the creatine group saw greater growth or gains in one arm squat, and the same was true in the jump squat. So clearly in healthy men, this study supports more or less what every other study says, that the gains on creatine will outdo those of placebo. Now this next study done by Alves et al. In 2013 is a little bit different, because this one examined creatine supplementation in fibromyalgia patients, which is a very unpleasant disorder. Now here they looked at 16 weeks of creatine versus placebo, where there was a 20 gram for 5-day loading phase. So that's basically 20 grams per day, 5 days, then a 5 grams per day after loading. So we can see the leftmost top figure shows creatine content in the muscle, and clearly the placebo was significant. The placebo group saw significantly lower increase in creatine than the supplement group. And then top right we can see the increase in leg strength in creatine group over placebo group, and bottom left we can see that the same thing was true in chest press, where in fact the placebo group declined and the creatine group saw a slight increase. And finally similar results, all of them significant results, of course. That's marked by the little dot above that bar, for those who don't know. There were significant results also in hand grip strength. So also in sick populations, strength was enhanced. Now next, let's touch a little bit on the types of creatine. I'm embarrassed to say I actually don't know who did this study. I just sadly recall it from class, but what this basically says is the top line that we look at is CRM, which stands for creatine monohydrate. Now the other ones are different forms of creatine, as not to how do you say, discredit or speak down on supplement companies, but there are a lot of modified versions, so to say, of creatine that are supposed to have better characteristics, absorb better, have more significant impact, so forth and so forth, and of course in turn cost significantly more, because normal creatine is extremely cheap. It's probably one of the cheapest supplements out there that I can think of, anyways. So anyways, what this study showed though was that the creatine saturation or the content in muscle was actually best through the creatine monohydrate, which is the top bar there. So the best one is basically the cheapest one. So anyway, so don't go ahead and buy expensive creatine if somehow you should think that this is actually a good supplement and want to go buy. Just buy the cheap stuff because it's good. Now here in the end I will add in a few additions on how and where creatine could be useful, though some of this is actually pretty complex and I don't want to go into it too much, also because I don't really understand it that well. However, some of the basics though. It should be noted that creatine is found in good amounts in both in parts of the immune system, and the central nervous system, and also the brain. So potentially the mechanisms it can work through, we can see here, for instance, it might have neuroprotective properties through increasing phosphocreatine and hence ATP, and also reducing these ROS, are called reactive oxygen species, which of course take part in oxidative damage. Also, it has been observed in this study by Reisenberg et al. In 2017, this is a recent study, that there is a decrease in interleukin 6. Interleukin 6 now is for those who don't know, interleukins it's a type of cytokine. It's a communication mechanism between cells, and this in particular is an inflammatory one. And this in particular especially is a big problem in chronic low-grade inflammation. It is one of the main inflammatory cytokines, along with what's called interleukin-1 and TNF-alpha, which is, for instance, also found in diabetes released by white adipose tissue. But anyways, that's a side note. So there is in this study they have found that at interleukin-6 was reduced. The TLR stands for toll-like receptors, but that's beyond the scope of this particular presentation. And also that in this from the immune standpoint, the ICAMs were upregulated. ICAM is an adhesion. It's an intracellular adhesion molecule, which is once again complicated, but it plays a part in how immune cells get to tissue where there's trouble. It basically is a little attachment mechanism that helps what's called rolling adhesion. But anyway, so what this study found was that, and we can also look at it in the airways. I thought it was interesting that it was suggested that it could improve or increase collagen content, and elasticity in fibers is actually one of the problems that happens in the lungs over time, is that the elastic recoil in the lungs are lost, and that can lead to all kinds of problems. So really the point that I would like to make with this, the study summarizes here by Reisenberg et al. In 2017, it summarizes on the side a few of these things, is that potentially there seem to be very many interesting applications where in fact creatine can be very helpful, and given that it really has very little downside, it seems to be, and it's very cheap and accessible, widely accessible, it seems to be a very decent supplement. Now, finally, maybe a little bit in the end of further potential mechanisms of creatine. It can affect a whole host of hormones, myokines for signaling mechanisms for muscles, insulin. If indeed, for instance, remember the GLUT4 vesicle, that's basically what insulin would trigger. So it seems that it can affect that, creatine, and growth factors and other hormones. It has been proposed. This is what we see in this graph. Essentially, is cell signaling, and this is complicated and maybe a separate topic in itself. But if we look at, for instance, if we recall how it affects ATP as an example, it helps replenish ATP. Then one should note that here we see energy AMP increases, AMP ATP ratio basically, so AMP increases. This starts an enzyme called AMP kinase. AMP kinase, more specifically, it initiates a pathway that phosphorylates something called tubercle sclerosis complex, which actually inhibits a binding protein. This is very complicated, but it inhibits a binding protein called the Rep binding protein, which then would otherwise, if not inhibited, phosphorylate mTOR. And mTOR, as we see, initiates muscle protein synthesis. So by not allowing AMPK, by blocking that AMPK through enhanced energy, it is possible that, for instance, creatine can help this mTOR complex and hence protein synthesis, which maybe on some level will contribute to the better or better muscle gains in elderly. As actually one of the things that happen as people grow older is they get increasing difficulty in phosphorylating this mTOR complex. So there, in short, there are many interesting mechanisms through which creatine can act. It can influence several components of this cell signaling cascade. So I realize I have, of course, to some extent in the studies I have discussed the dosage and loading. Recall that there really is, within reason, there is really no such thing as too much. Of course, that doesn't mean you should drink the whole box of creatine, but doses up to 30 grams have been shown in studies to be safe. However, here is a little bit on just to outline the dosing. So in general, times of increased blood flow seems to maximize distribution of creatine to skeletal muscle, because recall it travels through the blood. But really, studies also show that this timing doesn't matter all that much. It's not like it won't exert its effect if you don't take it during exercise. Then a loading phase is recommended, and this is just to obtain or reach quicker saturation, creatine saturation in muscle. And if you were to do a loading phase, then that would be about 20 grams per day for 5 days. You can break it into, say, 4 servings or so, 5-gram servings, and then following the loading phase, 3 to 5 grams per day will be sufficient. Also, to be noted, it takes about a month for the creatine to clear out of the system. So what is then the take-home message of this creatine? So basically, it is utilized to aid the ATP PCR energy system, which is a short-term energy source, about 0 to 10 or 14 seconds, where creatine kinase is elevated in days following intense exercise. This is like the really heavy eccentric loading where there's a lot of muscle damage. Creatine helps to reduce that, aid in recovery. Also, creatine supplementation increases size, strength, and it improves, of course, body composition. And the creatine monohydrate is the cheapest and also most effective form. And finally, a loading phase will be faster than a non-loading phase. So overall, the efficacy grade, if we can grade the supplement, should be an A. Because it's extremely effective, it works. There's a crazy amount of research. If there's anything that has a lot of research, it certainly has it. Very effective, very cheap. And also, above all, it is safe. So that kind of wraps up my creatine supplementation. I hope this was useful, and I will make additional ones, similar format, although this is actually the first one I make, so the formatting is not the best. I realize I am on 22 minutes, actually probably 25 by the time I'm done. I will try to cut these shorter into 10-minute segments. And also make a list up ahead of time so you can know what kind of supplements I will be covering. So you can skip the ones that are boring, not for you. If you're an endurance athlete, this might be pretty boring. But I will cover basically main supplements for every energy system that seems to have some sort of effective efficiency or effectivity or something. So anyways, hope that was useful. See you next time.